There's a whole bunch of different perspectives and vantage points when it comes to performance. Common viewpoints include from the user's viewpoint, from the application's viewpoint, from the host, the network, or even the storage array's viewpoint. And the point to note here is each sees things at a different angle or from a different perspective, as well as seeing detail in different areas. Let's quickly look at each a little more closely, as all of these viewpoints are important. First up, the user viewpoint. Like we said earlier, if you're trying to buy something online and the website's so slow that you can't make the payment, then something's definitely wrong. You don't care if the storage array or if the network both check out as healthy and are reporting no performance problems. As far as you're concerned, from your viewpoint, the system's either down or it wants shooting. Then there's the application. If the application can't connect to the database, even though the storage array or the network report everything is all clean, as far as the application's concerned, there's an issue. And as a storage administrator, you need to be armed and able to defend yourself against accusations from users and application owners. These guys tend to be fond of pointing the finger at storage when the going gets tough. When this happens, and it does happen often, you better be ready to defend yourself. Then there's the host perspective. The host gets to see end-to-end performance, such as latency, but it usually can't drill down into the kind of detail required outside of the host. So for example, if a host is seeing high latency, and the host itself looks to be in good shape, low CPU, low memory utilization, as well as no queuing and the likes, the host usually is not able to drill into network or array-based detail to diagnose whether or not the cause of the latency exists in the network or in the array. The host's great for drilling into host details and metrics, as well as giving that good end-to-end view, but it usually can't give detail about the network or the array. We've mentioned queuing. What is queuing? Hosts and storage arrays maintain queues, which are effectively buffers on either HBA ports or storage array ports, and these buffers store pending IOs for a given volume. Queues can speed up performance, especially on spinning disk-based systems, as applications and hosts can queue multiple IOs to a volume while it waits for the volume to actually service the IOs. The size or number of IOs that can be queued is known as the queue depth, and a queue depth of 32 allows you to store up to 32 pending IOs for each volume, whereas a queue depth of only 16 only allows you to queue 16 pending IOs for a particular volume. And as we mentioned, host HBAs and storage array ports both have queues, and it's best practice not to allow the combined queue depths of all hosts connected to a storage array port to be more than the queue depth of the actual storage port itself. For example, a storage array port with a queue depth of 100 that has 10 hosts attached could allow each host to have a queue depth of 10 each, without overrunning the queue depth of the storage array port, which is 100. But if each host had a queue depth of 11, then they could theoretically or potentially overrun the queue on the storage array port, because all 10 hosts, if they used all 11 of their queues, that would add up to 110 queues, and the storage array port, as we said, only has 100 queue buffers available. Now, queue depth can be a tricky topic, and you should consult your array vendor or maybe their array's documentation before tinkering too much with queue depths. Then there's the network, be it a fiber channel SAN or Ethernet. The network is obviously the string that connects the hosts and the storage, and it can be a potential cause of performance-related problems. However, the network, like the others, doesn't give detail of anything other than itself, so the network doesn't give detail about the application or the storage array. At the network level though, performance-related port stats, such as port throughput, can be monitored to tell you whether or not a particular port is being saturated or pushed too hard. And this can be particularly useful, especially for things like oversubscribed ISL ports, or for FCIP, fiber channel over IP ports, which are used for replicating fiber channel traffic over IP networks. The output that we can see on the screen now shows the output of a port perf show command on a Brocade fiber channel switch. The command is showing the transmit and receive throughput for the first 6 ports on slot 1, and the command was told to run and update the view every 5 seconds. That's why we have 4 rows of output. We ran the command for 20 seconds. Now, as we can see, for slot 1 port 0, here at the top left of the screen, we can see that the port is transmitting 2.6K but receiving 236K. So it's receiving a lot more traffic than it's transmitting. But neither of those are high numbers. They don't even break out of kilobytes into megabytes a second. So we know that that particular port is not being pushed hard. And last but not least on the list, the array. The array has no detailed view of the network, the host, or the application performance, but it does have intimate knowledge of itself. Now, each of these viewpoints are important, and each usually has its own tools to provide the appropriate relative detail. Network tools for network detail, array tools for array detail. You get the picture. And any good performance monitoring solution is one that's able to drill into detail at each of these levels and then glue the whole picture together and provide good real-time as well as historic and baseline statistics. And in order to troubleshoot many performance issues, you really do need that complete and comprehensive end-to-end view of the estate. Let's take a look now at some of the stats that are generally available from host-based performance tools.